parallel circuit is a circuit with two or more different paths for the current to follow. If this is like a neighborhood and you're driving around, all right, I can go down that and get back to where I started, or I can go down this path to get where I started. If this bulb burns out and the electricity can't get through the middle, it can still go around the outside and this bulb will stay lit. So if you need to tell a parallel and a series circuit apart, you can unscrew the light bulbs, and if other light bulbs stay lit, it's parallel, has to be. Now current, if the current comes into a parallel circuit, let's say we have 14 amps, all right, and it splits up, it will not split up equally because these resistors could be different, and we'll see this here in a moment. So we could have 3 amps of that current going down one branch, 5 amps going down another branch, and then 6 amps going down a third branch here. What do we notice though? 3 plus 5 plus 6 equals 14. So that current splits up, and then it comes back together to be 14 amps again. This is idealized. You know, in real life, probably going to lose some energy to heat, but we have to kind of recognize that this is an ideal situation, and that's going to allow us to practice our calculations. We need total resistance for the parallel circuit, but total resistance in a parallel circuit is a little different. You see the formula for it here. 1 over total resistance equals 1 over the resistance of the first resistor plus 1 over the resistance of the second resistor, and so on for however many resistors you need. My gosh, what is happening? Let's look at an example, break it down. You can do it. All right, for this circuit, 2 ohms, 3 ohms, 4 ohms. Same resistors, same light bulbs we had in the series circuit, but now they're arranged differently, so it's going to be different. 1 over R total equals 1 over 2. The 2 comes from here. 1 over 3, the 3 comes from here. 1 over 4, the 4 comes from here. When you're doing calculations in physics, write everything out so you don't get lost. I've seen so many students say, I'm going to live in my calculator, I'm going to do the steps in my calculator, I'm going to get an answer. You're not. All right, maybe you'll get the right answer, but someday if you keep going forward, take physics in college, they're going to get you. Write it all out. It'll help you keep track of where you are. So 1 over 2 plus 1 over 3 plus 1 over 4. Now, depending on how good you are with the calculator, you can do that in the calculator. You need to get the parentheses in there so your order of operations is good. iPhone calculators are just stinky in general. Or you can do, simplify it. 1 over 2 is 0.5. 1 over 3 is 0.33. You can round it. 1 over 4 is 0.25. And then you add those together. At the end of the day, however you do it, for this one you should get 1.08. So if you want to try this in your calculator, adding the fractions, go ahead. If you don't get 1.08, if you get like 1.07 something, that's close enough. But if you don't get anywhere near here, then something went wrong in your order of operations on your calculator. We're not done, okay? Because our total resistance is not all by itself over here, so we need one more step. To get our total resistance, then we have to take 1 divided by whatever number we got here. 1 divided by 1.08 is 0.93 ohms. All right? You can go through, you can do the algebra to see how we got from here to there. It works out. Or if you just want to kind of remember that you have to take 1 divided by whatever your answer you got up here. That'll get you your total resistance for the circuit. What can we do with that with Ohm's law? All right, we got a 12-volt battery. So if we have our total resistance, well, let's calculate the current. Current equals voltage divided by resistance, and we have to use R total, the total resistance for this. So current equals 12 volts divided by 0.93 ohms equals 12.9 amps. There we go. All right, now we know how much current is here, and I've made sure to write it right there next to the battery because that is like the main street in our circuit. What do I mean by that? Well, if we use Ohm's law for each one of these branches, let's look at that. Okay, for this first branch, 12 volts divided by 2 ohms equals 6 amps. This branch, 12 volts divided by 3 ohms equals 4 amps. And then for this one, 12 volts divided by 4 ohms equals 3 amps. All right? The total current that we just found over by the battery doesn't go down each branch. It splits off. And the less resistance you have, the more current you're going to get down that branch. So now if we label everything and we round it to 13 amps, we got 12.9, but that's because we're doing some math on our calculator. If we round it to 13 amps, we see 6 plus 4 plus 3 does equal 13. So there's kind of two methods to get the total current here by the battery. You can use the total resistance of the circuit, and then you'll use that with the voltage, or you can figure out the different branches, and then you can add those branches together to get the current. There's lots of different ways to do things, whatever you feel more comfortable with. This would definitely be some level 4 math. It's not difficult, but there's more steps than we would like. We'd like to be everything one step and done. This is not that. All right, give it a shot though. You can do it. Let me know if you have any questions.